All right, so the other day when we were working with our mystery compounds, we were seeing compounds like this, CaCO3. Well, now we're actually going to take a look at them and count how many atoms are in each of these molecules. So we have a Ca here. There's no number, so that means one Ca. Look at the C. There's only one C there. No number, so that's one C. But now we got O, and it has a 3 next to it. That means 3 oxygen. That's all you got to do to count them. All right, so let's take a look at another compound, peroxide. We have 2 H's and 2 oxygens. That's what the numbers represent. These represent our subscripts, which break it down. Now we're going to take it to the next step, and we're going to get a little bit more complicated here in a moment. All right, so now we got a compound with a parentheses in it. It looks scary. It's not. We're still using the distributive property from math class. Just like in math class, what we're doing is going to be contained within the parentheses. So this 2 is going to get multiplied by that compound, by that element, and that element. You notice I'm not coming over to the Ca. The Ca is not in the parentheses, so it doesn't count. All right, so let's take a look at inside this parentheses. Inside the parentheses, I have 2 Cas, 3 hydrogen, and 2 oxygen. And that's just in the parentheses. But remember, we said that this 2 is going to be multiplied by it. So we actually have 2 more oxygen, 3 more hydrogen, and 2 more carbon. Now, are we done with this formula yet? No, because we still got the Ca. So we got to put the Ca out here. So how many carbons do we have? We have a total of 4. How many hydrogens? A total of 6. How many oxygens? A total of 4. But our calcium is a solo single one out here. The idea when we're counting molecules or counting particles in a compound is to look at this 2. Well, what does this 2 mean? It means we have CO2, CO2. We have the compound twice. But we're scientists. We're lazy. We're not going to write this twice. We're just going to put a number 2 up here. Now this 2 in the compound here follows the distributive property in math. This 2 is multiplied by that C and multiplied by the O. So what I have are 2 carbons and 4 oxygens. All right, so now we got sodium carbonate. We have our particles. Now let's write the formula for this. So we have our first one of Na. How many Nas do we have? 2. So we'll put a subscript 2. How many Cs? Only 1, so no subscript, because I'm lazy, I don't write a 1. And then we look at our oxygen, and we have 3 of those. So this is how you write the formula. This is how you go backwards from the particles to the compound.